This is section 1-3 entitled Asymptotes. Now just to review, what is a vertical asymptote and what is a horizontal asymptote? Okay? If you look at our diagram here, you will see in green that is the horizontal asymptote. It's what the function approaches but never actually reaches, okay? So it gets really close at both ends here, but it never really reaches that asymptote. The vertical asymptote is a dotted line, the vertical line in red. Again, it gets really close up here, and it gets really close down here, but it never touches. So that's what we mean by a vertical and a horizontal asymptote, where the function gets really close to, but never really touches. All right, so let's look at a vertical asymptote. Here's an example here. I've got a function, all right, and x squared plus 2x minus 8 over x squared plus x minus 12. It's wherever the denominator is 0. All right, so first thing I'm going to do is I'm going to factor both of these. If I factor both of these, I end up with x plus 4 potentially canceling, and I'm left with x minus 2 over x minus 3. Now, if we look at this, as I say, x plus 4 canceled, x minus 3 is going to be 0 when x is equal to 3. So therefore, I have a vertical asymptote at x equals 3. So how does this apply to limits? Let's look at an example here. We're going to have the same function as we had before, but now we're going to ask for the limit as x approaches 3 from the left-hand side. Well, we take and factor this, and we take and again get to the point where we can cancel both the x plus 4's out, and we're left with x minus 2 over x minus 3. Now, we're approaching 3 from the left-hand side. So, that means that it's going to get really close to 3, but never equal 3. So say it could be 2.99. If the numerator, if x is 2.99, the top, 2.99 minus 2, that's getting really, really close to 1. The bottom, 2.99 minus 3, is going to be a negative number, but it's going to be a really small negative number. So if I have 1 over a really small negative number, our answer is negative infinity, okay? So the limit of this function as x approaches 3 from the left side is equal to negative infinity. All right, so now let's look at a slight variation of that. The same function, but now we're going to have x approaching 3 from the positive side. Again, I can factor the top and the bottom, all right? But now we're approaching 3 from the positive side. So it's going to get really, really close to 3. So the top is going to be 3.0, let's see. It's going to be very close to 3. So the top is getting very close to 1. The bottom is getting really small, okay? It's going to get really close to 3, but it's never going to equal 3. But it's positive, okay? So now let's look at the horizontal asymptote. Another way of looking at this is end behavior. So as x goes really close to infinity, in the positive infinity, what's happening to the function way out to the right or way out to the left, okay? And we're looking to see if it approaches a specific number, all right? Now, the basic rules state, if the denominator grows faster than the numerator, okay? That means you're approaching 0. That means you have a horizontal asymptote at y equals 0, all right? Now, if the denominator and numerator grow equally fast, okay, then obviously you're approaching 1, and you have a horizontal asymptote at y equals 1. Now, if you happen to have coefficients in front of the x values, then it will equal the ratio of the coefficients. And you'll see what I mean in a second when I give you an example. Now, if the numerator grows faster than the denominator, so the top is growing very fast, the bottom not as fast, that means you're approaching positive infinity, and if that's the case, there is no horizontal asymptote. Okay? So those are our basic rules for horizontal asymptotes. All right, so let's look at some examples. So I got 3 examples here, and I want to determine the horizontal asymptotes, if any, of the following. So let's look at the first. We got y equals x plus 4 over 3x squared minus 5. Now, as x gets really, really, really big, we can ignore the 4, we can ignore the 5, and in fact, we can factor this x with one of the x's on the bottom, and the result is going to be the only thing left is going to be this x on the bottom. That's going to get really, really big, so you're going to have 1 over a really, really big number, or in other words, you're approaching 0, or the asymptote is at y equals 0. All right, let's look at the second one. We've got y equals 2x plus 4 over 3x minus 5. Again, we can ignore the 4 and the 5 because they'll have limited effect on this. Now, I've got 2x over 3x. Well, technically I can cancel out the x's, and let's see what we get. So all we're left with on the second example is simply 2 over 3. So that's what this is approaching, so therefore we have an asymptote, horizontal asymptote at y equals 2 over 3. All right, if we look at the last example, again, we can ignore the plus 4 and the minus 5, and the x squared in the top becomes x. We cancel it with an x in the bottom, and let's see what we get. And that means it's going to approach positive infinity, all right? So therefore there is no horizontal asymptote on this, for this example. All right, let's look at an example here. We've got the limit as x approaches infinity of the square root of 4x squared plus x minus 2 over 3x minus 1. Well, first of all, the 2 and the 1 have very little effect on this because x is going to get really big. And in fact, since we got an x squared term, adding x to it is going to have little impact. So we're left with basically the square root of 4x squared over 3x. And the square root of 4x squared is simply 2x, all right? And we've got 3x in the bottom. We got x over x, so as x gets really big, those are going to pretty much cancel each other, and we're going to get for the final answer that the limit is simply equal to 2/3. Now this is a case where the numerator and the denominator are growing at the same rate, but we've got the coefficients here, so that's why instead of this being 1, this is 2/3 because of the coefficients. So that's how we're going to talk about asymptotes and limits.